Morning, students. This is the revision part number 2. Okay. So I have come up with some set of problems. This is the first problem. So am I audible? In the chat box, yes or no? Anyone, please? Am I audible?
Yes, ma'am.
And design a finite automata for the regular expression. Okay. So this is in the case of a regular expression to finite automata conversion. In this part, in our textbook, actually only one case is possible: regular expression to epsilon and fa conversion. Okay, the other two cases are not covered in the syllabus. So, design a finite automata for the regular expression means it is indirectly meant by regular expression to epsilon and fa conversion. The regular expression which is already given. Okay, so as you have already know, actually this part is already having a theoretical theorem part in the mode of induction. There are three cases, right, for union, concatenation, as well as clean closure. Kindly recall the content. Okay, there are three cases actually. So 0 plus 1 whole closure. So here 0 plus 1, which is in the form of union closure. Okay, then 0 0 plus 1 1. Here 0 0 means which is in the form of concatenation. Okay, so I have to separately first drawn and then combine all the three into a single automata, but I am going to directly draw this automata. So 0 plus first, I will start with 0 plus 1 closure. So 0 plus 1 closure means first I will start on starting state. And this is for epsilon. 0 plus 1 whole closure means 0 plus 1, right? 0 plus 1, which is in the form of union. If it is union means, okay, if it is union means you have to actually there are two parts: the upper part for the first part 0, the lower part for the second part 1. Okay. So this is for actually epsilon, and this is for epsilon, and this is for 0, and this is for 1, and this is for 1. Then again join with epsilon. Okay, so actually this part, actually this is the part for 0 plus 1. Okay, so 0 plus 1 closer means I have to add one more with epsilon. Okay, one more with epsilon. Then closer means one loop is added, epsilon loop. Then from this to this one. Okay, this is also added. This is also epsilon. Okay, so this is for 0 plus 1 whole closure. Next, concatenation with 0 0 plus 1 1, right? So again I will add one epsilon for the concatenation, and also this is in the order 0 0 1 1. So I will consider like A equal to 0 0 and B equal to 1 1 means A plus B union format. So union format, this is in the format union format. So this is epsilon, this is epsilon. So the upper part which is 0 0. So concatenation with 0 0. So this is 0. Next is 0, that is that which is in the form of concatenation, right? So concatenation with means in between one epsilon is added. So 0 epsilon, then 0, here 1 epsilon, next 1. Okay, then again join with again joined with an epsilon. Okay, so this is in the form of a 0, 0 plus 1, 1. Next, concatenation with 0 plus 1 again. Actually, this is 0 plus 1 closer. Okay. Then you will again starts with epsilon. This is in the case of epsilon. So 0 plus 1 which is in the form of a union, right? So epsilon, epsilon. This is for 0. Okay. Sorry, it is almost see 0 plus 1 closer, right? 0 plus 1 closer. So, and this is for closer. Okay, 0 and our lower part which is closer. So, this is, I will add one more epsilon. Okay, then 1. Okay, then this, then epsilon. This is the closer part. Okay, so 1 which is closer, right? So this is the closer part. This is 1 closer. Okay, see 0 plus 1 closer. So this is the part of 1 closer. Again, one more epsilon with your final state. Okay, and finally we'll a number, make it as every state with 1, 2, 3. Okay, this is the final step. So this is the your epsilon NFA. So this is nothing but epsilon NFA. This is the only one cases which is available in your textbook. Okay. So this is the conversion of regular expression to finite automata. Okay. So this problem is over. Then next one. This is also one of the repeated question. Pumping lemma. Okay, so prove that L equal to 0, I square, where I is an integer greater than or equal to 1. Okay, so you have pumping lemma means, so now you are going to prove this language is not regular, right? So the solution part. So in the first step, is in the pumping lemma, the first step, first let assume that because pumping lemma concept which based on the contradiction, right? So assume that the given statement which is true. Okay, then prove that the given statement which is wrong based on the contradiction. So let L is a regular language. L is a regular language. Okay, so what about L? So L here, L is actually for I equal to 1, greater than or equal to 1, right? If I equal to 1 means 1 square. So 0 power 1 square which is 1, then 0. I equal to 2, 2 square, right? 2 square which is 0 power 4. So 4 times 0. Then 3 square, 9. Okay. Then 4 square means 16. So like the way this will come. This is the language. Okay. The second step, the L has a pumping length. As usual, I will choose the pumping length P equal to 4. L has a pumping length pumping length P, where P equal to 4. So all the strings in L having length greater than or equal to P can be pumped. This is our assumption. All the strings, the strings which is nothing but a language which is a collection of strings. All the strings L having length, that is having pumping length greater than or equal to P, okay, can be pumped. This is our assumption. So in the next step, I will choose the pumping length. Let us choose S equal to this one 9 times 0. Okay. So the next step, we are going to pump the string. Pump the string. Pump the string means S can be divided into X, Y, Z. Okay. This is the essential basic steps. So I will select the string 9 times 0. Okay, so this is for case number 1. Probably you are using almost 3 cases, which is preferable for a part B problem. Okay, if it is part A means only 1 case is enough. So in this case, so I will choose the first 3 which is X, and second 3 which is Y, and one zero, 9 times zeros. Okay, so third part which is Z. Okay, so I have to take X, Y power I, Z, right? So assume I equal to 2. You will take I equal to 2. This is also your assumption. So then X, Y square is Z. So X, what is X? 3 times 0. Y square, what is Y? 1 time 3 times 0, again 3 times 0. What is Z? Again 3 times 0. So actually this is in the format of 0, 12. 0, 12, which is not present, which is not a format of a language, this language, right? Actually this language is in the form of 0 power 4, 0 power 9, 0 power 16. So like that. Okay. So what's the 3 conditions, pumping conditions? The first pumping condition, which is X, Y square is Z, whether it is belongs to L or not. Second, length of X, Y less than or equal to P. Then length of Y greater than 0. Actually, this condition is not satisfied. The first condition is not satisfied. Second condition, length of X, Y, length of X 3, length of Y again 3, 3 plus 3, 6, 6 less than or equal to 4. Wrong. So length of Y greater than 0. Yes. Okay. So only 2 conditions are satisfied. So you will choose two more cases. In the second case, you will choose the first 2 as X, the remaining 4 which is Y, and the last 3 which is Z. Okay. In the case number 3, you will choose first 4 zeros as X, second 0, 2 and 4 is 5 and 6 for Y, and the remaining part which is Z. Okay. So like but I have covered only 1 cases. Okay. So this problem which is almost over. Next, so prove that the class of regular sets is closed under complementation. Actually, this is not a 13-mark problem. Okay, it's almost this is maybe a 6 mark. Okay, So I will come in the last, in the third. This is the one important problem. Minimize the automata shown in a figure below and show both the given and the reduced one are equivalent. Okay, that is minimization of automata. Okay, so this problem will consider minimization of automata. So, what are the methods are available in minimization of DFA? Anyone post here? The name of the methods which is available for minimization of DFA. Yes, one is a table filling, right? Good. What's the second method? Actually, two methods are available in minimization of DFA. Important problem in unit number 2. Yes, partitioning method. Good. Okay, I will choose partitioning method. Okay. Because it will take a less time compared with a table filling method. Okay. See here in this problem, actually they have not explicitly mentioned as you have to use the table filling or you have to use partitioning method. Okay. So the choice is yours in your hand. So you will choose either a table filling, which one is good for you. Okay, either table filling or partitioning method. So I will choose partitioning method because it will take less time. So compare with a table filling. Okay. So first, the first step, I will check uh, here with what which one is the starting state. Q naught is the starting state and Q4 is the final state, right? So I will check all the states except I will check all the states, see whether all the states are reachable from the starting state. Okay, here starting state is Q naught. So all the states Q1, Q2, Q3, and Q4. We will check whether all the states are reachable from starting state because um, a DFA has some dead state, right? So we will check all the states are reachable from the start state or not. I will check Q1. Q1 is reachable from Q naught and Q2. Q2, which is all which is also reachable from Q0, right? This path. How do you reach Q2? Actually, many paths are available. One, this path which is also available, and also from Q0 you will go Q1, then again Q2, right? Next Q3, Q3 which is also reachable from Q0, then Q4. So Q4 which is also reachable from Q0. So all the states are reachable from the starting state. Okay. If any one state which is not reachable from starting state means you can eliminate the state in the computational part. Okay. No need to add the state in the computational part. Okay. So all the states are, so in the step 1, so all the, you have to write the in the step 1. All the states reachable from Q1, Q0. So this is step number 1. So in the step number 2, actually no need to draw transition table. Okay. And the step number 2, what is step number 2? Post in your chat box. Recall the content and post in the chat box. Step number 2. in partitioning method. If you are having your TOC note means TOC note in your hands means, then you can check a previous content and post the answer. What's the step number 2? What I should find? That is, anyone? Zero equivalence, right? What do you mean by zero equivalence? You have to start with zero equivalence. Zero equivalence means you have to separate the states from final states as well as non-final states. Okay. Yes. Final and non-final. Okay, that is zero equivalence. So zero equivalence. The zero equivalence, I have to separate non-final and final. So the non-final states are Q naught, then Q1, then Q2, then Q3. So these are non-final states. Then what's the final state here? Final state, which is Q4. Okay, this is final state. This is zero equivalence. Okay. So next step, you have to find the one equivalence, right? So you have to find the one equivalence. So for finding the one equivalence, so you will take the pair, this one pair, like this one pair. Now you will compare this pair and again compare Q naught with this pair. So again compare Q naught with this one pair. Okay. So how means, first I will take the pair Q naught Q1. I will take the pair Q naught Q1. So what about the transition on 0? What about the transition on 1? Okay. See, Q naught on 0. So Q naught on 0, it will goes to Q1, right? Q naught on 0, it will goes to Q1. Q1 on 0, Q1 on 0, it will goes to Q2, right? It will goes to Q2. So this is one pair. Okay. So I've identified this is the pair. You will check this pair which is in the same group or not. Okay, so you will consider the previous. For calculating one equivalence, you will take the constraints on the zero equivalence. Okay, see in the zero equivalence, the Q1 and Q2 both are in the same group, right? Both are in the same group. Okay, next one transition on one. So Q naught on one, it goes to Q3, Q3, then Q0, Q1 on 1, Q1 on 1, which moves to Q4, right? Q4. See, in the zero equivalence, this pair, which belongs to a different group, Q3, which comes to the first group, and Q4, which comes to the second group, right? So, actually, this pair is separated. See, Q1 on 1. So Q naught on 1, it goes to Q3, which is in this group, okay. But Q1 on 1, okay, it goes to Q4, right? So Q1, which is separated from this group, okay. Say, once again, I have repeat this. For calculating one equivalence, okay, you will take the pair first Q0 Q1 pair. You are going to check whether the Q0 Q1 which is available in the same group are separated. Okay, so Q0 Q1 on 0 transition, both are coming to the same group. Okay, both are coming to the same group. Q1 and Q2 both are in the same group. but based on the transition on 1, okay, but the group is separated. Q3, which is in the same group, but Q4 is separated. How can you calculate Q4? Q1 on 1. Okay, Q1 on 1, it moves to Q4. Okay, so Q1, which is separated. Okay, so I will write one equivalence. So I will a different group. A group is formed Q1. Q1 which is separated from this group. So Q naught. I could not write all the things as per right now condition. So I'm going to check the further pair. Okay. So this is for the pair Q naught and Q1. So to encounter this pair, Q1 is separated. So next I will come up with the next pair Q naught and Q2. Okay. So Q naught and Q2. Actually compare with all the units, actually the unit 2 which is the most confusing you are definitely went on the confusion state while working the problems on unit 2. Q naught and Q2. So the transition are 0 as well as 1. Okay. So Q naught on 0. Q naught on 0, it goes to Q1. Q2 on 0. Q2 on 0, it goes to again Q1, right? Q2 on 0 again goes to Q1. Okay. Then Q naught on 1, it goes to Q3. Then Q, Q2 on 1, it goes to Q4. Q2 on 1, it goes to Q4. Okay. So based on the transition on 0, actually Q1, Q1, so definitely the same group based on the 0 equivalence. What about the second one? The second one, actually the group is separated, right? Or the Q3, which is in the first group, and Q4, which is in the second group. So Q2 is separated. Okay. In this is actually not in the same group. So Q2 is separated. So I will check the Q2 with Q1 because Q1 is already separated. So I'm going to check whether Q1 and Q2 both are making a same pair or not, same group or not. So I will check Q1 with Q2. Okay. In the first step, all the states are reachable or not. Okay. Second step, 0 equivalence. Just divide the group based on final as well as non-final. In the first equivalence, in the first step, in the first equivalence, Q1 is separated, right? In the second step, in the first equivalence, Q2 is separated. So I will check whether Q2 is making a group with Q1 or not. Okay. So this is the pair. So 0, 1, Q1 on 0, Q1 on 0, it goes to Q2. Okay, Q1 on 0, it goes to Q2. Q2 on 0, Q2 on 0, it goes to Q1. Okay. Next, Q1 on 1, Q1 on 1, it goes to Q4. Okay. Then Q2 on 1, right? Q1 on 1, it goes to Q4. Q2 on 1, it goes to Q4. See, based on the previous 0 equivalence, Q2 and Q1, which is in the same group, right? Q2 and Q1, which is in the same group, and Q4 as well as Q4, which is also in the same group. So I can combine this Q2 with Q1. So I will write Q1 comma Q2. Okay. Is it clear? Yes or no? So kindly instruct here, please. Working out more problems on, especially for unit 2. Okay. Because all the problems are having two approaches, like minimization of automata, minimization of DFA, two approaches, table filling, partitioning method, as well as finite automata to regular expression, also two approach. One method RAJ method, the other one state elimination method. Okay, so a lot of approaches are available in unit number 2. So definitely it will make you a confusion state. Okay, this is actual, so I'm not finished. So next pair Q naught, so Q0, Q1, which is over, Q0, Q2, which is also over. Next Q0 with Q3. Okay, Q0 with Q3. Q0, then Q3. So 0 as well as 1. So Q0 on 0, it will goes to Q1. Then Q3 on 0, it goes to Q2. Then Q0 on 1, it goes to Q3. Then Q3 on 1, it goes to Q4. Okay, Q3 on 1, it goes to Q4. Actually, this is one of the very tedious uh, problem which I have ever found in the partitioning method. This is one of the tedious one. See, first group as Q1 and Q2, the same group, but the second one Q3, Q4, this is in the different group, right? So definitely Q3 is separated. So as per this situation, Q3 is separated. So I'm going to check with the remaining pair Q1 and Q2. I'm going to check with this pair Q. Okay, so I will. So Q3 separated. So in the zero, in the one equivalence iterations, already two states are separated, Q1 and Q2. So I will just check with the pair Q1. So Q1, Q3. Okay. So Q1, Q3. So 0 as well as 1. So 0 as well as 1. Q1 and 0. Q2. Q3 on 0. Q3 on 0. Q2. Okay. Q1 on 1. Q4. Q3 on 1. Q4. See, both are all the pairs are same state. Okay. Next, I will check with Q1 with Q2 also. So Q1, Q2. Sorry, Q3. This is Q3. So I have checked with Q2. Okay. So any doubt? Any doubt? So Q2 with Q2. Then Q3 with Q2. Next, Q2 with 1. Next, Q3 with 1. Q4. Actually, this pair which also belongs to the same group, right? Q1, Q2 based on the zero equivalence, Q1, Q2, which is in the same group, and Q4, Q4, which is in the same group. So I will combine this Q3 with Q1, Q2. Okay. Actually, this is the first equivalence answer. Okay. Yes. Yes. Any one method which is good for you. Actually, you will prefer either table filling, else partitioning. So I want to need some feedback. Which one is better, table filling or partition? Kindly post in the chat box. Which method are you prefer for minimization of DFA? Table filling. So what about others? So what about others? Which method is the right and easy one for the minimization of DFA? So almost 139 people are here. Okay. I'm not only asking to Nandini, I'm asking to all you people. Okay. Trying to post the answer, which is easy for you, table filling or partitioning. I want to make some analysis report. Table filling. Then the partition is the first one, right? So what about others? Table filling. Okay. So no one is partitioning method. So table filling is the easiest one, right? Okay. So once the class is over, we will take this problem. Okay. So kindly note down the problem, the diagram, etc. So problem. Okay, take a picture and send it to my WhatsApp number. Okay. And in parallel, anyone please work with the second equivalence, whether I have reached the same set of pairs or not. I want to check. Okay. Anyone please working with two equivalents. So this is the so in the two equivalents, actually see the two equivalents also actually we are in the ending state. Almost we are in the ending state. See, this is the two equivalents. So in the two equivalents, I will check the pair, right? So here in the group number one, there is no pair to check. In the group number two, again you will check Q1 with Q2, right? Q1 with Q2, then Q1 with Q3. So you in Q1 with uh, so in see actually 4 minutes are there, right? So I will check Q1 with Q2. So Q1 Q2, the based on the zero Q1 on zero, Q1 on zero Q2, then Q2 on zero Q1, Q2 on zero Q1. So based on the one Q1 on one Q4 and Q2 on one, which is also Q4. So this is the second equivalence. I will check with one equivalent Q1 and Q2, which are in the same, which belongs to the same group, and Q4 in the same group. Okay. So next, I will check with Q1 with Q3. Okay. So Q1 with Q3 for 0 as well as 1. For 0, the Q1 with 0, Q2 and Q2 with Q3 with 0, Q2 and Q1 with 1 and Q3 with 1. Both are belongs to the Q4 only. So in the one equivalence, Q2 and Q2 same group and as well as Q4 same group. Okay, there is no more no any change in this zero equivalent. The same result. Q0, next Q1, Q2, then Q3, then Q4. Okay, so this is the ending stage. Okay, so this is the ending stage. Okay, so there are how many states are available in your minimized DFA? Only three. Only three states are available in your minimized DFA. So you are In the next step, we are going to draw a DFA. So based on the states Q0, second state, which is Q1, Q2, Q3, and third state Q4. Okay. So in the next step, you are going to draw this one Q0, then Q1, Q2, Q3. So Q0, which is your starting state, and Q4, which is your final ending state. Okay. So Q0 on 0, Q1, same here. Then Q0 on 1, it goes to Q3. That is 0, comma 1, 0, comma 1. Okay. So Q1, all the zeros are in the same state only, right? Then all the ones are, see, Q1 on 1, Q2 on 1, Q3 on 1. So so all the states are going to Q4 only. Next, self loop. So this is your minimized DFA. Okay. So this is your minimized DFA. So is it clear? Yes or no? Clear? Thank you, students.